Hi everybody, Patrick here from EngineeringShock.com, electroniclessons.com, and paintballprops.com. This is tutorial video 6, how to make a vibration detector using our Arduino Protoboard, currently on Kickstarter. The link is below, as well all of the other videos for this project are linked below as well, so you can watch them if you're interested. I've got a lot of other projects going on in the Protoboard area of this project, such as a microphone and light-dependent resistor circuit, but we're not using those. We're just using our LCD, our two onboard LEDs, and our A1 output, our analog to digital port 1, A1. So if I knock on the table, vibration detected, and the LEDs toggle back and forth, back and forth, back and forth. I'll do it again. Vibration detected. And so it'll just continue to do this. It's a very, very simple project that you can use to build on. Everything is commented. All of the code samples that I make for these videos will be available to people who pledge towards a Kickstarter. But even if you're not interested in pledging towards a Kickstarter, you can follow along with this video because I'm going to talk about the circuit, the connections, and the code, again, which is very much commented. So let's talk about the circuit. This circuit is very similar to our microphone circuit talked about in previous videos. But we're going to replace the microphone with the vibration sensor. And there's actually two things you can do here. What the vibration sensor is it's a contact. It's two contacts. Essentially, when you shake it, they make intermittent connection with each other. So there's a 10K pull-up resistor, and so there will be 5 volts at the top of the vibration sensor. But when the vibration sensor moves and that contact is made, it shorts that 5 volts to ground. So basically, right in the middle of the 10K ohm resistor and the vibration sensor, you'll get 0 or 5 volts. It'll be a square wave because when the vibration sensor is detecting movement, it's shorting, not shorting, shorting, not shorting. But we're not going to use essentially the on-off. We're not going to use a square wave. We have more control if we couple the AC signal over the C1 0.1 microfarad coupling capacitor. Now what this does is it does two things. It blocks the DC component on the left side of the circuit, and we should see 0 volts on the right side of the circuit through that coupling capacitor unless the vibration sensor is detecting movement, at which point little AC pulses will couple across that C1 capacitor. We've got a pull-down resistor of 47K, same one used in our microphone circuit, and this will bleed off any ambient noise at that end. And we're going to feed that AC coupled signal to our A1 line on our Arduino Protoboard. So when the vibration sensor detects movement, that signal is fed to the ADC, the analog to digital converter, takes that signal, converts that analog signal, and changes it into a digital signal. And we'll get to that when we talk about the code. The connections from the first of the two vibration sensor circuits are outlined in red. The CP2A output is circled in red, as we would have connected that to the LED, but the secondary circuit is outlined in green and in blue. The output CP1A is circled in blue as well, but we went a little bit further and connected that to the input of the 555 timer. And the output, the DLY output on the main pin block, is connected to the LED. The VAR1 and the DLY potentiometers, variable resistors, are circled in blue as we use those in the second circuit. We're going to break this section down into two parts, as there's a function called void blink, or blink, below, which we don't have room for on this page. We'll get to that in a short segment in just a minute. From the top left, we include our liquidcrystal.h, our LCD library, and this will help us use our 1602A LCD with greater ease. We'll declare the control pins for the LCD as 4, 5, 6, 7, 8, 9, which connect respectively to RS, E, D4, D5, D6, and D7, as talked about in the connections portion of this video. We'll define a button as GPIO2. We're not going to use this for this specific video, but we'll declare it right now for later. We'll define LED1 as GPIO0 and define LED2 as GPIO1. And then there's a commented section here that talks about how you'd connect your LCD to any specific breadboard or circuit. We'll create an integer called result, and we'll give it a value of 0 to begin with. Next, we'll do our void setup. We'll set up our LCD as 16 characters per line, 2 lines. Then we'll clear our LCD, wait 200 milliseconds. Then we'll we'll declare button, which is GPIO 2 as an input, LED 1 as an output, LED 2 as an output, and again we'll declare int result as 0. It's not necessary to do that again, but it's there nonetheless. Void loop. So now we're going to loop this section over and over and over again. As you can see, void blink is below, but we'll get to that in just a second. That function, we're going to call it to blink the LEDs 50 times, to toggle the LEDs on 15 times. Anyhow, what we'll do is we'll take an analog read of the A1 line and store that digital value into result. If result is greater than 100, then then what will happen is the LCD will display vibration detected. We'll set up the LCD cursor to the upper left, 0, 0, and we'll print vibration in the middle of the top line. Then we'll set the LCD cursor to the second line, which is 0, 1, the lower left-hand corner, and we'll print detected in the middle of the second line. Then we'll call the blink function, which we'll get to in just 1 second. And once the blink function has completed, the LEDs have blinked back and forth 15 times. We'll clear the LCD and we'll start from the top, at which point the device will take another read from the A1 line. It will keep reading the digital value on the A1 line until that value is greater than 100. And nothing will happen until that happens. The LCD will not say anything. It will not move further on in the code until result equals more than 100 after we bang on the table or shake our module. Now let's talk about the void blink function. When we call the blink function, we set up a for statement that will execute the code 15 times and then return. So for int b equals 0, b is smaller than 15, b++ means that every time the code is executed, the value for b will increment by 1, and once it becomes 15 or greater, the code will return to where we called it. And the code in the for statement is very easy. We digital write LED 1 high for 100 milliseconds. Then we'll turn that LED off and turn LED 2 on. Wait 100 milliseconds, turn LED 2 off, and then repeat the code again 15 times until b equals 15, and then we'll return back to where we called it in the void loop, and then we'll clear the LCD and go back to the beginning of void loop. So there you have it. That little blue vibration sensor in the back detects my knock. Vibration detected. Very simple. Hope you enjoyed the video. Hope you found it educational. If you haven't already checked out our Kickstarter, again, the link is below. Have a gander if you have a minute. Thanks for watching, everyone. Have a great day.